And with that, I would like to hand over to our next speakers, which will be Gerd Datzmann, and he will give us an introduction about radiation test facilities. So now we know something about space weather, we know something about radiation effects to electronics, but the question really comes, okay, how to test and where to test, because obviously we can go the risk in just flying into space and see what happens, but this is something we want to prevent, and we want to evaluate and test electronics on ground first. And yeah, with that, I would like to introduce Gerd. Gerd is a physicist by education and specialized in nuclear and accelerator physics at the Technical University of Munich. And during his PhD work, he developed and operated nuclear microprobes for high energy protons. In 2016, Gerd founded his own company. In his position as managing director of Datzmann Innovative GmbH, he provides a portfolio of service centering in accelerator applications and in the field of advanced material analytics, protons therapy, and radiation hardness testing. And Gerd will give us an introduction about the RADNEX project, which is building a network about radiation facilities.
Thank you, Jan. Thanks for having me first, and thanks for giving me the opportunity now to present the RADNEXT EU project, which I personally think is a very good project that fosters and strengthens the field of radiation hardness testing. So we learned from Andrea that there are a lot of single event effects out there. And this is the reason why space agencies worldwide since decades have formulated standards and more or less require electronics that go to space to be tested and qualified beforehand. And this now leads to a very interesting relationship and interesting business relationship between the users of this radiation hardness testing, that can be companies, that can be space agencies themselves, or even academics on the one side. And on the other side, we have the irradiation facilities. And since RADNEXT is dealing with basically with single event effects, this always means that we are dealing at the irradiation facilities with large particle accelerators. And this makes it now special because the irradiation facility sells a service to the user while the user is paying a fee. But on the user side, we kind of have a free market. So the demand is there, but on the irradiation facility side, this is not a free market because mostly all of them are publicly funded facilities and are not part of the free market. So, and this was one of the reasons that the RADNEXT project, or the idea for this project, started in 2019 to foster the community and to bridge the gap between both sides even better than it was at that time already, although there were already a lot of facilities doing these tests for external users. Yeah, so RADNEXT basically is an infrastructure program that is funded by the European Union and is coordinated by Ruben Garcia from CERN. It's a distributed network in this field of radiation effects with, again, I said, a focus on single event effects. And the strength, or what makes this program very powerful, is the huge consortium that has been found. It's about 21 irradiation facilities, a lot of academic partners and supporters, 4 agencies and research institutes, and of course, a huge number of industrial partners and supporters. So in total, we have 31 beneficiaries plus 8 associates. And the project officially started in 2021. Was determined to be 4 years, but just very recently it was prolonged by 1 year until May 26. So the 3 pillars that this project is resting on is the so-called joint research activities. I will not have the time to go into that today. Then we have the networking activities. This will be the second part of my presentation today, and the so-called transnational access, which is the hugest part from the budget side and also from the resources and effort side. And I would like to start with that. In total, the whole project has 10 work packages, and 12 PhD students and postdocs are paid and involved in that. And I recently read a number that about 130 people are working here together. So let's dig into transnational access. Here you can see again a map with the 20 facilities we have in Europe, very nicely distributed, and the one facility in Canada. And transnational access means basically creating availability for the users to go to facilities and do their tests. But it's a very special program. It's more than 6,000 hours of beam time that will be awarded in the duration of the project. And this is done via a competitive proposal process. So there are quarterly calls for proposals, which are then evaluated by experts. And if your project or campaign has been chosen, it's free of cost for the users because it's funded by the European Union. Nice is that it's eligible for both academic and industrial groups. And again, the strength of this project is the diversity of radiations or beams that are available. Of course, we have protons and heavy ions, which are heavily used for the space applications, but we have also neutrons for ground level applications and some more alternative and maybe non-standard things like mixed field or synchrotron X-rays, where we will hear for both of them additional talks after my talk. I would highlight a bit on these portfolio of facilities we have, and I would like to start with the proton facility overview. In total, we have 7 facilities providing protons, and you can see here on the left side that they cover different energies. It's a log scale here, and we have some facilities going from sub-MeV protons up to some hundreds of MeV. Typically, the range for testing is more here in the middle, but you can choose whatever your application is requiring. And in terms of fluxes, again, a logarithmic scale here, we have also kind of a variety for people who need lower or even higher fluxes. So these are the proton facilities. Going to the heavy facilities, I think we have gathered almost all 5 facilities that are providing these type of applications to external users. It's the UCL Belgium, RADEF in Finland, Partec in Netherlands, Ganil in France, and GSI in Germany. And here is a plot where you have the range of the ions versus the LET value. The LET value we heard from Andrea is the important value of the damage to the device. And we can see that we can go up to some tens of 60 MeV per square centimeter per milligram. Down below, you have these so-called cocktail facilities that can do different ions. You can see here the different species and switch beyond them in a very short time. And then for these much higher energies, you typically have only one single ion, but you are able to vary the energy to have different LET levels. So for completeness, I also show the neutron facilities, although it's not really relevant for space, but we have in total 10 facilities there also with different energy ranges. Some statistics on what we have achieved so far in terms of transnational access provision. The status is from February this year. Until then, the total number of submissions was 315, a quite impressive number, I would say, in 10 calls. And you can see that a bit more than 50% of the submitted proposals were already also accepted. So that's also quite nice number. You can see here in the graph also the distribution over the calls. It's really varying a lot, from a few tens of proposals up to even 60. This is a huge effort also from the team who is distributing, because it's a single point of contact. So you write this proposal and then our expert will evaluate it and distribute it to the different facilities. So a lot of administrative work. And so far in the first 2.5 years of the project, we have already delivered 3,000 hours of beam time and another additional 1,000 hours that have already been assigned to the facilities. But of course, we are going ahead. Another slide is here about the distribution among the different radiation types. And it's not surprisingly that the space applications like heavy ions and protons are the most contributions and the most requested ones, but also neutrons for, as I said, ground level applications, and mixed field and other are still there and are in demand. We are really proud in the work in that concerning industry. We have already had 20 campaigns accepted. 16 of them are performed with a, I would say, quite impressive number of 500 hours dedicated to industry, having involved 13 individual companies from very small ones to even big ones. So the call for proposals are still ongoing. I mentioned in the first slide that there was an extension of the RadNext project. So the next call for proposals will start in January, will be open the whole month. And there will be 2 other calls next year until the last call in September 2025. And here is the QR code where you can enter the web page, where you can look at all this information I told you now and can apply when the proposals are open. And with this, I would like to change to the networking activities. The networking activities we could summarize in the area of outreach and dissemination, like promotion of the project and showing what we do, engaging the people. Then we have a lot of support and educative measures within the program. And of course, the topic of networking, technology transfer, like bringing this community together even closer, is at the heart of this project. And I will give you in the next slides a couple of examples and hopefully things that might be also of interest for you if you are intending to do tests and using our RadNext program. The first thing is more facility information than what I gave you in this very short and broad overview is in the AIDA database. It's hosted by CERN, and there's even a special register on the RadNext facilities. All 21 facilities are in here with some more details on the technical parameters and they have. In addition, the RadNext organizes a few webinars per year. These are typically about facilities that even might not be in the RadNext project, but are, for example, abroad, like here in Australia or the US. And even the webinars that have already been performed can be viewed on demand at the RadNext webpage. So again, here's the QR code. And if you're on the RadNext webpage, we really would like to that you subscribe to our newsletter, because then you will become information about webinars, about the new calls for proposal, and so on. I don't want to go into detail on that. I just want to say that we are also doing studies on best practices within the facilities. For example, there was a huge study which was meant also to harmonize and even provide better and more professional the service to the users. and also encourage and maybe help facilities that currently do not or only very occasionally serve external customers to tell them what are the best practices to do so. The last, or maybe the next to last topic is the so-called GRAD Next workshop series. And well, this is our special channel to industry that we established. Means we do every year a workshop where the target audience is definitely the industry, the companies that are doing these radiation tests. But of course, we also invite the facilities and research infrastructures for presenting their way and the academics in this field. And of course, also the agencies are part of these workshops so that we really bring together the whole community and foster the networking and of course the knowledge transfer. The objectives is we want to engage with you and want to provide you a platform where we can collect also the industrial requirements and needs, but also inform about the facility landscape, about the perspectives from the application sides, and many other things. So typically these workshops are going 2 days and have in the order of 25 to 30 presentations. You can see last year's event here with more than 80 people on site at the CERN campus. And this year we had the same number of participants at the campus of the Rutherford Appleton Lab in the UK, a neutron facility. And yeah, we are currently working on the next workshop, which takes place next year in May at the Ganil site. This is in the Normandy region of France, a heavy ion facility. And it is again an in-person workshop. We will have 2 full days with interesting program that we are now currently putting together. There will be also, of course, a site visit to Ganil and a social dinner. And all our workshops are free of charge for the users. So please engage with us. We will open the registration very soon in January next year. And you will be informed via our newsletters, for example, and about this program. And my last slide is another interesting and very fascinating activity within the RadNext project. It's a massive open online course on radiation effects in electronics that is at the moment prepared. It's basically led by Igor Aguiar, and a MOOC is a measure to have easy access to high educational content in this very special field that we put together. The target audience is undergraduate to graduate students, but of course, anybody who is interested in that topic can go to that. I don't want to go into the details, but it is a 5 weeks program, self-paced, with 5 modules about many different things you heard already today in a very short way, but this will be, of course, be extended lectures on radiation environments and on mechanisms, on testing, mitigation, and so on. The expected launch date will be in the first semester next year, and we are very proud of that initiative, and we will see what's happening. So once again, thanks for your attention. Here's again the RadNext webpage where you can find all our activities and measures. Thank you.
Thank you, Gerd, for the nice presentation and introduction to the RadNext project. Obviously, very interesting for people interested into radiation testing. And I think the major takeaway with that is that people could, I don't want to say easily, but more easier get access to facilities, and even with that free of charge. Just to have a comparison, I mean, radiation test facilities are generally rare on the market, specifically when it comes to commercial beam time. at least from European side, and also maybe from the US side. And usually those radiation test facilities, specifically when we're talking about particle accelerators, are extremely expensive. And maybe you know some numbers, but I do have some numbers in mind. We are talking about, let's say, thousands, or let's say at least a minimum thousand euros per hour by using those facilities. And with the RadNext project, you can get this free of charge, or let's say funded by the European Union. One important question maybe to the audience, or let's say one answer to the audience would be, do we have restrictions, or are there restrictions for applications just only from the European side, or could even people from US or somewhere else in the world can apply for beam time?
So definitely it is open also for the rest of the world outside of Europe. The number of proposals that are accepted should not exceed 20% for the rest of the world. But I think that is we are still within that limit, so it's eligible also for people from outside of Europe. And maybe one restriction we can say, especially when it comes to commercial users, it is not eligible to let's say projects where these companies earn directly money with it. So it's forbidden because the EU cannot subsidize companies with this measure. So it always needs to be some kind of scientific interest, R&D project that is not in correlation with a commercial project companies do. So this is one important thing. And the next, and there's another, well, maybe minor thing you need to remember. You cannot apply for a facility within your own country where you are, only all the other countries around you.
Yep, makes sense. Regulations from the European Union. Excellent.
Exactly.
Thank you very much again for your presentation. And yeah, all to the attendees, just make sure if you're interested into this project and would like to apply, you have the QR code here, and also in the presentation maybe available later on.